In the 1960s, there was a very famous psychological experiment done by a bloke called Milgram, where he got a bunch of participants to electrocute a subject in another room to varying levels of pain. And we can imagine, although this probably wasn't exactly how the experiment worked, but the participants probably had a dial where they had to move the dial to a certain number, and the further up the number was, the more the subject was being electrocuted and the more pain they were in, and the students participants could see this person being in pain, and the whole point of the experiment was to see how far up the dial they would move the dial. Of course, the participant wasn't really being the student wasn't really being electrocuted, but the participants didn't know that. Anyway, let us imagine, just for the sake of this video, that the results in the 1960s were the following: that the mean was 7, that the standard deviation was 1.2, and that a particular participant who they were very interested in seeing how he or she performed relative to the other participants, their Z-score was 3.4. Now, it doesn't matter if you don't know at all what that means, because that's the entire purpose of this video. So let's leave that for now. Let's imagine in 2023 a student wishes to repeat this experiment, obviously with the correct ethical considerations, and they want to compare 2023 results to the 1960s. And the way to do that is they need to use certain statistical methods. So let's imagine that they get 5 students and they get them moving this dial to see whether or not they can fake electrocute a subject in another room who they think are being electrocuted. And let's imagine, to the sake of argument, there are 5 participants. And let's imagine that the scores that they move, let's imagine that S1 moves the dial to 6, and S2, the next participant, moves it to 4, and S3 moves it to 3, and S4 moves it to 8, and S5 moves it to 9, moves the dial to 9. These are the 5 participants. This here is called the raw data. Now, with the raw data alone, we cannot compare the 2023 experiment to Milgram's 1960s experiment to see if any conclusions can be drawn about what 2023 people would do relative to 1960s people. We need to do something with this data. Now, the first thing that we do with our data is we find the mean. Most people are pretty comfortable with the concept of a mean. All the mean is basically that we add up all of the raw data. We add up all of the raw data. 4, add 3, add 8, add 9, and then we divide it by the number of participants, which gives us 30 over 5, which equals 6. So the mean is 6. Now, in mathematical terms, you will often see this written as mean equals sigma x over n. All that means, n is the number of participants, x is each of the scores, i.e. 6, 4, 3, 8, 9, and sigma, all it means is sum them up. That's all it means. So the mean is the sum of all of the participant scores, the x's, over the number of participants, and that gives us the mean. Okay, now if we just look at the mean on a number line, and here is the mean here, which is, say, 6, and let's just look at each one of the students. So S1 got a 6, so he is here. Actually is at 6, and S2 was a 4, so he's down here. That's S2, and S3 is a 3, so he's down here. That's S3, student number 3. Student number 4 was an 8. He moved the dial all the way to 8, so he's S4, and S5 was a 9. He moved it all the way to 9. We can see that there is a variation. There is a between each of the participants and the average, the mean, which was 6. What we want to do now is we want to see how big is this variation, how much does it vary, and the way to do that is a thing called variance. Now again, I'm going to do the formula first, which looks scary and isn't. The variance is the sum of x minus m squared over n. Again, sigma, the sum, we've already discussed that. All it means is add them all up. X minus m squared is basically the difference between each of the students' scores and the mean, and we square it. Now, why do we square it? Well, if we take student S2, for example, here, his score is 2 under. And if we take student S4, his score is 2 over from the mean. If we then added up student S2's difference from the mean and student S4's difference from the mean, we would get minus 2 plus 2, which equals 0, which isn't very helpful in the slightest. If we square that difference and we square that difference, then their numbers will be positive. So we have 4 and 4, and we add the squares up. Now that's why the variance is the square of the difference between each of the participants' scores and the mean. Okay, so now we can do a little table here if we want to. S1, S2, S3, S4 and S5. Let's just remember their scores. Their scores were 6, 4, 3, 8 and 9. Okay, so now we can do x minus m, which is basically this part of the variance here, which is going to be, so 6 take, the mean, remember, is 6, so 6 over 6 is 0, 4 take over 6 is minus 2, 3 over 6 minus 3, 8 take over 6 is 2, and 9 take over 6 is 3. And now remember, let's square it, because that's what the variance is. It's going to square, so let's square it. 0, 4, 9, 4 and 9. And the variance is the sum of this squared divided by the number, which is 5. So 0 add 4 add 9 is 13, add 4 add 9 is 26. So the variance equals 26 over 5, which equals 5.2. Okay, now that gives us an idea of the square. The next concept, which is really common in statistics, is what's called the standard deviation. And the standard deviation, all it does is it sort of reverses what we've just done by squaring the distance. And all the standard deviation is the square root of the variance, which gives us an average each participant was away from the mean. Now, the standard deviation, you often see it written as SD, but also you see it written as mu, which is the Greek character, Greek letter in the alphabet, mu. So the standard deviation or mu, is the square root of the variance, and the square root of, which is the square root of 5.2, which is approximately 2.28. So the standard deviation of the 2023 result is around 2.28. Okay, so what does that mean? What that means is, on average, each participant, they moved the dial around 2.28 from the mean. Now, before we compare the 2023 results to the 1960s results, let's just have a look at one more thing. Let's imagine that we were interested particularly in student number 5. Let's imagine he was the real focus of our study, and the first 4 students were maybe controls or whatever. If we wanted to see what student 5 did specifically relative to the mean, we would use what's called a z-score. Now, the z-score, what it does is it is equal, mathematically, is x minus m over the standard deviation. And if we want, we can use standard deviation instead of mu. It doesn't matter. And basically, so for student S5, we know that his score was 9, and we know the mean is 6, and we now know the standard deviation is 2.28. So student S5's score was 1.32. What that means is that student S5 moved the dial around 1.32 times as much as the average participant moved the dial from the mean. So what we can do now is we can compare these two experiments. So if we go right back and just look at the 1960s experiment, if we just remember, we had a mean of 7. We had a standard deviation, which should now make a little bit more sense, of 1.2. And we had a participant z-score, the one that we were particularly interested in the 1960s. His participant z-score was 3.4, and in today, in the 2023 experiment, we have a mean of 6, we have a standard deviation of 2.28, and we have a participant z-score of 1.32. We can now directly compare the 1960s experiment to the 2023 experiment because we've got rid of the raw data and we put it into statistical terms. So we can say, we could even actually draw a graph. Why not do that? Let's draw a graph. So here is a graph, and let's put the 1960s results in blue. Probably makes sense. So here's the mean, 7. Now, because the standard deviation was 1.2, that means the average participant was around 1.2 from the mean. So if that's about 6 and that's about 8, so the average participant, so this would have been roughly the 1960s. So there's the mean of 7, and the average participant is around 1 or 2 from the mean. Now with the 2023, we can see that the average the standard deviation is much wider, and the mean is slightly lower. So the mean on the 2023 is now 6 instead of 7, and it's a much wider curve. So basically, it's more like that, which is much wider, rather than this one, which was much narrower, and the mean is slightly lower. Now our participant z-score in the 1960s experiment, he was 3.4 times the standard deviation away, so his score was somewhere up here, well off the charts in the 1960s experiment. So clearly he moved the dial far more than the average person in the 1960s moved the dial. And if we look at the participant in 2023, he was 1.32, so he was only around slightly more moving the dial than the average participant. Now, if we wanted, just one final thing before we finish this video, if we wanted to actually find the participant's raw score, we have the raw score of the participant in 2023, we have his raw score was 9, and we also have, that was his raw score, and his z-score is 1.32, but we only have the z-score of this person. How do we find the raw score? Well, in actual fact, the raw score, just by simple, because the z-score is equal to x minus m over sigma, then the raw score, this is the raw score equals z sigma add m. So we could find the participant in the 1960s raw score. His raw score is simply his z-score, which was 3.4, times 1.2, which was the standard deviation in the 1960s, add the mean, which was the mean in the 1960s, which gives you 11.08. So that was his raw score was 11.08. So we can deal with his raw score if we want to, which as we've put over here, that is around 11.08, so that's correct. Okay, so you can see that the whole point of using statistics in psychology is that we can compare experiment results, and rather than using raw scores, which really, if we go all the way back to the raw scores that we had here, these raw scores here don't tell us anything in comparison to the mean, the standard deviation and the z-score from the 1960s. But once we put the raw scores into mean, standard deviation and z-scores, we can directly compare them as we did here.